Hello, grade sixes. I'm just going to do a little quick lesson on these Cuisinart rods that you can use for fractions that some people will find handy as manipulative. So just going to go over how we can use them. And you can see I've got all these different colors there. So I've got some blue ones, some yellow ones, some red ones, some brown ones, and some green ones. Okay, now we're not like they are different lengths and stuff like that, but for our sense and purposes, we're not worrying about how long they are. We're just worried about what color they are, and they're going to identify different amounts, like a whole number. Oh, it could be halves, thirds, quarters, fifths. Okay, and it's up to us to determine what they're going to be. So I'm just going to show you what I've chosen for today. Okay, so you can see on the paper. Okay, I've got blue rods, whole. Okay, so I got those blue ones. Okay, that's whole. So that is a whole number one right there. And if I put another one there, that's representing a whole number two. Okay, so blue are whole numbers. And you're looking again on my sheet. It says red rods thirds. So I got these red ones. So that's 1/3. That represents 2/3 and 3/3. So if you have 3/3. 3 red ones equal 1 blue one. Because we know if you have 3/3, if you have a pie, you cut it in 3 pieces, and you still have all 3 pieces, you have 1 whole. So that would be an equivalent, okay? So red ones are thirds. You can see I've made green ones, sorry, halves. Okay, so I've got these green ones, that's 1/2. That represents 2 halves, which would be 1 whole. So if I had 2 of these, I could trade it in for 1 blue one. That would represent 1 whole one. So those are halves. And again, you can choose your own colors. I wrote mine down, partially for you, but partially for me too. So I have a record. I don't forget which was fifths, which was fourths. Okay, so I know for when I'm practicing. Okay. And I have yellow rods that are fourths, so quarters. So that is 1/4. So when you see yellow by itself, that's 1/4, 2 quarters, 3 quarters, 4 quarters, which of course equals 1 whole. And I could take that and I could trade those in for 1 blue one. Okay? Again, you choose the colors. Lastly, I have the brown rods down here. Okay? And these ones are fifths. Okay? So right now, 1 brown rod is 1/5, 2/5, 3/5, 4/5, 5/5. Okay, and once we have 5/5, we get all the pieces of the pie, that equals 1 whole. So I could trade that in for that. Now, if I want to just show you how I can represent some mixed numbers. Okay, so I'm going to take my sheet away, okay, and just do some work on here for you. Okay. So if I wanted to represent a mixed number, say 1 2/3, I have a blue one, which is a whole. So that represents 1, okay? And I have 1/3, 2/3. Right there, that is representing 2/3 in a mixed number. 1 and 2/3. Now, what could I do to turn this from a mixed number into a improper fraction? Pause so you can think about it for a second. Okay, so can I trade this for something? Okay, I'm going to trade the blue in for 5/3. Sorry, 3/3. 3/3 is a whole, so that's equivalent, 3/3. So 1 and 2/3 as a mixed number is 1, 2, 3, 4, 5/3 as an improper fraction. Okay. Now, what if I said to you, hey, how do I know which one is bigger? And I go, well, I've got 2 and a 1/3, or I have 10/3. And just looking at it like that, it's hard to tell, because a mixed number and improper fraction are harder to compare against each other. So what is a good way to do it is to put it to one way or the other. So I'm going to, instead of having this as a mixed number, I'm going to change this to an improper fraction. So I've got two whole ones. So think about how many thirds I can change that out for. Okay. So there's 3/3 and a whole. So I'm going to take this blue one and exchange it for 3/3. Okay, over there. I've got one more whole one. I'm going to change it for another 3. Okay. So now I see here where I had 2 and 1/3, I have 1, 2, 3, 4, 5, 6, 7 thirds. And over here I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 thirds. Okay, so this is definitely higher because now we're comparing apples and apples, so to speak. Okay, so I'm going to put that back. Okay, another example. Okay, what have I said? How do I compare? So green rods are halves. So say I have 5 halves. Or 2 wholes. Okay? 2 and, well, we'll say 2.5. Okay? So how are we going to compare these? Okay? So we could do it both ways. Let's try it the other way this time. So instead of making it improper fraction, we'll make it a mixed number. So 1/2, 2 halves equals 1 whole. So I will take that and trade it for 1 blue one, which is 1 whole. Now I have 1 blue one and 3 halves. So I still have an improper fraction. So I'm going to do the same thing, trade these 2 green ones for another whole, and I have 2.5. And over here I have 2.5. So indeed, they were exactly the same. So from Connect on page 285 of your textbook, it shows 1 mixed number and 2 improper fractions, and then orders them on the number line. So we've got 2 1/4. So that one, as you can see, goes 1, 2. So it's 1/4 of the way to 3, making sense. 2 1/4. 11/6. Well, 12/6 would be 2, so it's a little bit less than 2. So you can see right there. Okay, and then we've got 8/3. Well, 3/3 is 1, 6/3 is 2, and so it's not quite 3, but it looks like would be get like a 2/3 of the way between 2 and 3, 8/3. So kind of if you were to number them, would be from least to greatest. It would be 11/6 would be least, then 2 1/4, and then 8 1/3 would be the greatest. Okay, so now that we have this, I mean a more exact way for us to, I'm going to just change the thing, a more exact way for us to compare is to have like denominators. So let's take those same ones. We got 2 1/4. Okay, we got 11/6. We got 8/3. So first thing we got to do is we got to change this one to an improper fraction so it's easier to compare. So we got 2 1/4. Well, 2 is 8/4, and then 1. Okay, 2 times 8, 2 times 4 is 8 plus 1. So we got 9/4. 11/6, 8/3. Now we got to think, how are we going to figure out to compare these? Okay, 6 and 4ths and thirds, it's kind of confusing. So what can we do? Well, look at this. We've got 4ths, we've got thirds, we've got 6s. So what we can do is we can look at the multiples of these. Okay, so for example, 4 is the first multiple of 4, okay, then 8, then 12, 16, and 20. So let's stop there. Now 3, we got 3, 6, 9, 12, 15, 18. So now we got 6. So it'll go by 6, 12, 18, 24. So let's see if we have any common ground. Okay, so 4 is not going to work, and 3. So look here, 8, No, 8 doesn't work for these two. 12. So we got 12 here. 12 works for this one. Let's go. Oh, look, it works for 3 as well. And it works for 6. So it looks like 12 could be a common multiple. So now we got to go like this. So we got I'm going to start over here with 9/4, 9/4, and then we've got our 11/6 and our 8/3. So we want to get to 12. So what do we have to multiply 4 by to get 12? Yeah, 3. Okay, 4 times 3 is 12. So what we do to the bottom, we need to do to the top. So we're going to get 27/12. Okay, now we look here. We got our 11/6. What do we have to do to 6 to get to be 12? Well, you multiply 6 by 2 to get 12. So what you do to the bottom, you do to the top. So we've got 22/12. Okay? And then here, what do we do to 3, sorry. We multiply it by 4 to get 12. So we do the bottom, we do to the top, we get 32. So indeed, we were correct on our first one. Okay, this is the least, L for least. This is the G for greatest, and this is M for in the middle. Okay, but it's so now you can tell 32/12, 27/12, 22/12. You can really define them and put them exactly on a number line. Okay, so let's do that. Okay, I'm gonna erase part of this. So I ended up erasing the whole thing, and now I just rewrote our equivalent fractions at the top. We've got 22/12, 27/12, 32/12. Now it makes it much easier. Okay, now they didn't do this in the book. They just did 1, 2, 3 on the number line, but I did mine a little different. You can see here I've got 12/12, which is 1, right? Anything 5/5 is 1, 2/2 is 1, 4/4 is 1. So 12/12 is 1. But that just kind of helps us to be able to know when to do this. Then so I've got it there too. So it says 2, that's 24/12. 24 divided by 12 is 2. 36/12 is 3, and 48/12 is 4. That will just help us on this number line know how to order these in the right spot. So 22/12, well there's 24 and here's 12, so I know it's in between. Pretty close to right here, so I'm going to say, so right here is 22/12. Then I'm going to do 27. Well, here's 24 and here's 36. So in between is 12. It's like 3 up, so that's like a quarter of the way. So I'm going to say right there is 27/12. And then we got 32/12. Well, 36, it's not that big, and so it's between 36. So between 24 and 36, there's 12, and it looks like it's 2/3 of the way there at 8. So I'm going there. 32/12. Okay, so that's a kind of example of the connect and how we do it. Just going to go over, refresh the page, and just kind of review these equivalent, what to do with equivalent fractions. Okay. So if I have 4/5, okay, and I have 2/3, and I'm trying to make these equivalent fractions, I have to think of something, okay, that these have in common. Well, right away, I know if I go 3 times 5, which is 15, that's going to work because I know there'll be 3 will go into 15 and so will 5 because they're always when you multiply. So let's say we'll just try that for now. So we're going to go, we want these over 15. Okay. What do you do to 3 to make 15? Well, you multiply it by 5. We just said that. And what you do to the bottom, you do to the top. Okay. So 10 over 15. And then times 3 equals 12. Okay, so 4/5 is 12/15, and 2/3 is 10/15. So 4/5 is definitely bigger than 12/15. So once you get these common denominators, okay, the same denominators, then it's really easy for you to tell. Let's do one more. Let's say we have 3/7, and then we have 2/6. Okay. Now how can we tell? Well, one easy way to find a common denominator is to multiply the two denominators together. So 6 times 7 is 42. So we know. So what do you do to 6 to make 42? Well, we already multiplied. We already know that. So we multiplied it by 7, and we do to the top. We got 14 42nds. And then we do the same to here. We got, what do you do to 7 to get 6? You multiply by 6. The top by 6. We get 18. Okay, so 3/7 is 18 42nds, and 2/6, okay, is 14 42nds. So 3/7 is bigger. Okay, so let's flip over. We're going to start the practice questions, and then maybe we'll do the first one together. Okay. So we're on page 286. You're going to do numbers 1 to 11. Okay, but we'll do number 1 together. Number 1. Find equivalent proper fractions so that the fractions in each pair have the same denominator. Then compare the fractions. Use the symbols greater than, less than, or equal to. Okay, let's just do a couple. 8. Sorry. 8/3 and 6/4. Okay, so now we've got to find a common denominator. Okay, this like denominator that we can make these equivalent fractions. Well, we know that 3 times 4 is 12, so we know that'll work. So 8/3 to be something out of 12, and 6 out of 12. Well, what do you do to 3 to get 12? Well, this is easy because we know. We already multiplied by 4 to get 12. So times the bottom by 4 and the top by 4. Okay, and we get 32/12. We get there, multiply the bottom by 3. You do it top by 3. Okay, so 8/3 is 32/12. Okay, so now we know that we can say 32/12 is greater than 18/12. Okay. We'll just do B together, and then you guys can get on with the rest of the work. So B is 12/5 and 8/3. So sometimes when there's more than 2, like there was on the Connect, you might need to just list the multiples. So let's do it as the multiples this time. So we've got 5, 10, 15, 20, 25. And then go up for 3, 6, 9, 12, 15. Okay, well I can already see there we got 15. So 5 times 3 was going to work. Okay. So 12/5, okay, times 3 over, multiply the bottom to get 15, so you do to the top. We're going to get 36/15, and then on for 8/3, going to multiply top and bottom by 5, okay? So 8/3, okay, is bigger than 12/5, okay? And I can let you guys get on with the rest of the homework, and I'm here for any questions if you have them. Alrighty, thanks guys.